Hello, Fox Days Brussels. This is the last talk of a really great day. I've been following all the AI sessions, actually. There was quite a bit of overlap, so I'll try to avoid as much overlap as possible. But it's basically what you've been seeing, or who went to the AI talks, LLM, LangChain, Gemini sessions. Quite majority of the people in the room, so that's good. That's the hello world. That's where slides and demos on stage almost always work, right? But it's when you put it in production that it really shit hits the fan, so to speak, and that's what I want to talk about, is that how do you craft your own RAG system, and also how do you deploy it and keep it running, and should you actually deploy it? For the people who don't know me, I'm Stephan Janssen. I'm actually the person responsible of creating Devox. I'm also the co-founder, together with Mark Hazel, of Vox Days. So I've been doing Java for quite a long time, also Java champion, etc. And the cool thing about organizing a conference is that it takes about, well, we start 9 months before the event starts, but it's gradually building up this team. And then once Devox is finished, Devox Belgium, that's the one I organize, I have like 4 or 5 months where I can just relax and do research and development and play with technology. And that's basically what I want to talk about. So one of the projects I've built is the CFP, the Call for Papers application. And when I saw LangChain4j last year at Devox Belgium, I said, oh, I should build a chatbot. So I added the chatbot in the CFP, which was only for the admin people and the program members, where they could chat with the system and ask questions. And so one of the questions I asked was like, how many talks did Brian Getz give at Devox Belgium 2023? And funny enough, it answered, but it said 2 talks. That was not correct. How many talks did Brian give? Brian Getz give at Devox Belgium, if people were there. I did see some people with the Devox polo, but it's 4 talks, right? So what went wrong? It was like, how the hell is it unable to give me a correct answer for such a simple question, right? So I immediately decided, okay, 1, I will not put this public, we'll only use it internally, and 2, I want to actually debug and know why it was giving the wrong answers. And the talk is basically about this. It's my journey in how to actually find out what the hell went wrong, how can you fix it, or not, and also, you know, what I've basically learned throughout that journey. And I think you probably went to List Talk as well. I mean, when I was starting this prototype, this was in the news. Air Canada must honor the refund policy invented by an airline's chatbot. So that was already something like, okay, if these people, which obviously they have lots of developers, etc., are already not really successful in deploying this stuff, I probably will keep my chatbot private moving forward. I mean, and it reminded me of Richard Feynman's quote, where he said, I would rather have questions that can't be answered than answers that can't be questioned. Now, that doesn't really match completely to the large language model, so I make my own quotes, the Stephan Janssen quote. I would rather have questions that can't be answered than answers that are hallucinated, because that's what these large language models really love to do. They just throw you information and facts which they explain with lots of confidence, but they're actually not true. So what I did is that I'm a developer. I love to hack around, playing with technology. So I said, like, okay, I'll write a prototype. So this is not a proof of concept, it's a prototype. The difference between a prototype, a proof of concept, and something in production is that I don't have to write unit tests. That's what I explained to myself. A prototype is just hacking around. It's never going to go in production. It's just playing with technology. And because the CFP was already developed in Angular, I decided to reuse a lot of the Angular boilerplate code that I had used for the CFP, like the menuing system and the layout, etc. I was continuing with Spring Boot, wanted to use Java, 21 I used, and then of course also LangChain4j. So those were the 4 components or the building blocks for my prototype. And I will demo the prototype, and it's actually freely available, so I will share you the code. But like I said, there are some unit tests in there, but it's not like 80% or 90% coverage, no way. So the first thing I had to think about is that, what is the possible RAG flow, right? The Retrieval-Augmented Generation. If you've been to the different sessions this afternoon, most of the time they focus on the naive approach. Liz did go a bit deeper in the advanced one, but this is basically a step-by-step of what I've experienced and what I've tried to do with my prototype. Because what I wanted to do is not only implement an advanced RAG, but also debug everything what's happening, so I could actually pinpoint, where the mistakes are being made or where the pain points are. So the first thing, as you've already seen a couple of times this afternoon, we need to ingest information. So for me, I wanted to ingest the web pages and the frequently asked questions also about DevOps Belgium. But I also used a REST endpoint where all the speakers and all the talks are residing, and that returns JSON. So I'm calling to these endpoints, basically splitting the content, and that's already where shit hits the fan, splitting content. Guillaume and Liz, they just say, oh, you do splitting, you just take 300 characters, you do an overlap of 25 characters, and fine, that's all good. You will see later on, that's already where often problems arise. Now, if you do have the document loaders and the splitters, you embed those chunks, and then you start moving that towards a vector database. That's another thing. Who went to Alex's talk about vector databases? I loved his talk, right? I've seen it twice, actually. Really cool talk. There's also a few gotchas there, which I'll come back to later on. And so basically, the user enters a query. How many talks did Brian Getz give? We will embed that query to a vector, and then we do a similarity search in the vector databases where we try to find the vectors that actually are closest to your query vector. So that's basically the naive RAG. That's the first step that many of do. But there's already a few other things that actually happen. If I ask how many talks did Brian Getz give, or how many presentations did Brian Getz give, I will actually get a correct answer on one of the questions and an incorrect answer on the other, just because talk and presentation is interpreted in a different way. How the hell? I don't control the people who enter the question, so how the hell can you already anticipate that you get the right answer if you use talk and the wrong answer if you use presentation? Right. So there's already some techniques which are called query transformers, which actually create subqueries. So you create your first question, and then it will create variations of that query, and it might be using some synonyms where it will actually, by accident, use also presentation and talk in those different questions. And then you can fire those off. But keep in mind, that's already more than one question that you're going to be firing, so it's going to take more time. It's going to cost a bit of money as well, extra. But it's there. So in LangChain4j, which I'm of course using, it already has a query transformer where you can actually say how many variations of that query do you want in your system. And then you have the routing. So if you see there on the between query and embedding model, you have the embedding query, but you also have the router there. And the router can be as smart where it says like, well, I didn't really index any information about Brian Getz. Let me search and do also a public search where maybe Brian Getz talks from DevOps Belgium are still somewhere public, which Google can find, and it will take that result into the whole process, which is what we're going to get tomorrow in version 0.31 from LangChain, where they also support web search now. What I did, I used SERP API, so I implemented my own interface, basically. And SERP API, it does need a key, but it does allow you to actually search the web as well. So what you could do is that you could actually already have a routing where you don't choose, but you run it in parallel. So you can say, OK, go to the web, go to my RAG, my vector database, and by the way, use some tooling, which might be your web REST interfaces. And then try to collect all that information back, And then you can feed that to a big model like Gemini, where it has 1 million tokens, so you can give all that information, and it will figure out the right answers, because you're giving it all the context that you're looking for to answer that question, right? So that's already a bit more advanced, which currently, with the query routing, you could more or less accomplish that, but I believe that the query routing only follows one route. It doesn't do all of them. So, but it's open source, you can always change that, so that's another big issue. So the other thing that happens is that, okay, I have now some context which I can inject in the prompt. One of the techniques that also is being added is called the re-ranker. Liz actually talked about that, but a lot of people don't really use this. Why? Because you actually have to pay for the re-ranker implementation of LangChain4j, because it's based on Cohere. Cohere has a service called re-ranking service, and you have to pay for that. And I go like, come on, re-ranking, you have to pay for that? I mean, I don't like paying for these type of things which you could just implement yourself. So we have a lot of rainy weekends in Belgium, even in the week, actually. So if I can't walk the dog or go outside, I might as well do a small project. So what I did is I implemented my own re-ranker, which is based on the BM25 algorithm. I had no idea. I'm not that smart. But OpenAI, ChatGPT told me, yeah, re-ranking, you implement it with BM25, which is the best match 25. I have no idea what 25 stands for, but it's the best match. And there was a Python implementation. So I gave the Python implementation to LangChain. It converted it to Java. I tweaked it a bit, and I've got a working version of that, which you can find on my GitHub project, GitHub page. And it's very, very simple. You just basically start a new instance of BM25. You give it a corpus, which is basically your different chat messages. And then you can say, OK, do a certain search, for example, I love Java, and it will actually return all the responses which has these 3 letters. Now, this is not using large language models. It's more a semantic algorithm before large language models exist, but it will filter out these keywords that you're giving it, and as a result, it will reduce the number of contexts that you're injecting. It will reduce those lines of numbers, which I will demonstrate later on. So if you want to use this, have a look. The thing is, the coolest is that I'm doing these experiments, and of course, I know the founder of LangChain4j, so hopefully at one certain point, they will just copy the codes, which they can. It's just open source, and include it also in LangChain4j, which is cool. So you don't pay Cohere, just use this one instead. So then we have all the contexts that we found. We re-ranked them a bit. We now injected in the prompt, and now we send this prompt to the large language model. Now, that's where it doesn't stop yet. Because Liz, if you went to the talk from Liz, we have chat memory. So we keep track of all the chats that you're doing with the large language models, and it actually adds all the responses and the questions to your memory, and it sends that to the large language model. The problem with the current implementation is that there isn't any summarization. So if you're going to send like 500,000 tokens, it's going to be in the memory, and those 500 tokens will be included in the next calls as well. So after two chats, basically your window context has exploded because you've overreached it, and you might have paid a bit too much as well. So one technique that's it's an opportunity for a rainy weekend, is that you could, or you should, summarize actually what you put back into your chat memory. So that way it uses less tokens, it's more compact, and it basically includes only the essence of what you want to be talking about in your chat history. So if you look at this graph, I mean, that's a variation. There's definitely other things that you can add, and definitely there's a lot of things that can go wrong. That's what I want to say, and that's what I want to talk about in the next couple of slides. I've even forgot the last one. Sometimes you see these thumbs up, thumbs down. Well, the thumbs up, thumbs down actually gives feedback loop where if the answer was correct, you can actually use that as good answers, which are then again fed back into your vector database, because you've already answered a previous question which users have flagged as okay or not okay. So that's also a technique which currently is not available within, that's something you have to develop yourself, basically. Cool. So going back to my prototype, so that's what I wanted to implement. My prototype, I wanted to focus on some large language providers. I wanted to work with some local ones, so Olama, LM Studio, GPT-4All, and even Apple MLX. I wasn't able to do, but it's one specific for the Apple Silicon. And then I had some cloud providers, the ones with all the keys. And then I did not finish Gemini, because Gemini, it's only since last week that us Europeans now also have the API key accessible. But those are all the ones that I've actually used. Now, the cool thing of having all these LLM providers is that you can actually start comparing all the different, not only the different providers, but also all the models that these providers support. So that becomes really very interesting. And there's like this leaderboard that you should have a look at, which actually lists all these providers and the models they support. It's really very interesting. So the first one is importing the data, the ingestion. As Liz already mentioned, there's already quite a few existing classes from LangChain which allows you to ingest data. But ones that aren't supported is, for example, JSON and REST. So I implemented my own. I actually built like a small wizard where it will do a Swagger introspection. So Swagger is like a documentation of your REST endpoint. It will list all the different methods which are available, and then it will return the JSON that it's available, and you can select the fields that you want to include. And this was already one problem I had with my naive implementation. My tools, they went directly to the REST endpoint, and they took the full JSON. But the JSON was too big. So when I was actually embedding it, it was losing a portion of the JSON information because it was too big. So there was one talk from Brian Gutz where they had 4 speakers, and the talk returned the bio of the 4 speakers. And as a result, the JSON was too big to be embedded, so I was losing information. So that was already one of the reasons why I couldn't find all 4 of them. It's only when you're doing this stuff that you see that. So I implemented a filter where you can select the fields that you want to have and don't include, for example, all the bios or whatever. The same for JSON, for JSON as well, which is, of course, what REST returns. And using LangChain, it's very straightforward. Liz already showed you quite a lot of demos, but it's like 5 lines of code. Underneath, it uses JSoup. JSoup is like this, the Java version of the Soup Python version, which basically allows you to get the content out of an HTML and only get the content and not all the styling and all the other tags that you aren't really interested in. So this is very easy to load text from a URL. And then becomes the splitting. So the splitting, that's where it's to split or not to split. I mean, the question would be like, if you have a 1 million token window context, why would I split my content? Well, keep in mind, last year, when we were playing with this, the maximum window context was 4,000 tokens. That was it. So there wasn't even, there weren't any other options. You had to split it in almost 4,000 tokens and then actually use these chunks in your retrieval. These days, like since last week, now that we have access to Gemini, 1 million, I mean, seriously, that's a lot of window content. You can put almost 30,000 lines of code into it. That's almost a whole project that you can just dump in there and then start asking questions. I mean, Google is the only one with 1 million. Claude from Anthropic can go to 200,000 tokens, but eventually a window context will just disappear as a concept. I mean, all of these, especially in the cloud ones, they will just support unlimited. That's even the goal from Microsoft and Google, have unlimited window context with whatever techniques they have. Even in the labs, they already have 10 million, which is not yet accessible. And there's some interesting techniques. Actually, one of the speakers at Devoxx Belgium last year, Greg Kamrat, he actually invented a new technique which is called needle in a haystack. So what he does is that he puts a certain information in a document which fills the window context, like the needle, and then he asks a question if that needle can be found with that question. And some models will actually degrade if you put the needle further down the stack. So here, this is an example of ChatGPT with 4, with 128K, and you start seeing that at the end of the window context, it's starting not to be as accurate anymore. However, Google actually took this idea of a needle in a haystack, and they applied it to Gemini with 1 million, and it was almost perfect. So it was able, and I think Guillaume mentioned that, well, demonstrated it with the quote from Neil Armstrong, that it is able to find it. But it depends which model you use. So you have to really be careful, is that use this technique. If you say, oh, like Claude, if you want to use Claude Opus, which is one of the better models out there, which has 200,000, do the needle in the haystack test, because it's possible that it's not as good as the Gemini one. So that's already a very important one, and make sure you take a picture of that, or you'll have the presentations online on YouTube. Have a look at Greg's website, which explains the whole needle in a haystack approach. And so the other one is, of course, pricing. You have to watch out, because if you do the 1 million, it's going to cost you, right? I mean, they make a differentiation between what you put into the model and what you get out of the model. So the input and the output has a different pricing, because often the response is much smaller than what you put in there, right? But there is, it can really add up. If you look at the Claude one, it's $15 per 1 million tokens. $15. I mean, the demo that Guillaume did, that was $7 for his 500K presentation if he would have used Claude. Luckily, Gemini is a bit cheaper. But still, it's going to add up, so watch out. So that's why RAG is still very, very needed. It not only removes hallucination because you're giving it facts in the context, but it is also a much smaller window context because you're only getting the juicy parts that you're interested in based on the question that the user asks, right? So you have to weigh these things depending a bit on your use case. So RAG, I mean, I thought when Gemini would come out with 1 million that we wouldn't need RAG anymore. That's not true. Because if Gemini or like Claude, for example, like Claude is a bit behind because they are not that accurate with the latest and greatest information. Like they will have a cutoff of certain data, of certain information that they've indexed, and then it stopped. So like LangChain4j, it's not in there. We need to include it still using the RAG principle to actually get that information. Or for example, if you have your own private company information, that's not going to be indexed, so RAG is a way to still get that information in there. So it's going to be more accurate. And so splitting, LangChain4j has different techniques. You can see them there, and the example on the right, you can see the different implementations. It's very straightforward. You basically give it a chunk and a small overlap. So if you have a long text, it will say, okay, give me 1 chunk of 100 characters, and then maybe 10 characters overlap, so you have a bit of overlap. But it's a bit like, well, how does that work? And I'll show you how I've actually visualized that in my prototype after this slide. But there are some more sophisticated ways of splitting. And again, Greg, I mean, he's really doing a great job in promoting all these new creative ways of doing splitting. One is, which he actually suggested in this YouTube talk, which you can find on his channel, a semantic splitter node parser. So a semantic will actually split the content on the semantic meaning. So not on a sentence where we say, okay, split everything where there's a dot, which is the end of the sentence, but it will try to combine sentences which have a semantic meaning and then cut it when there's a new semantic meaning happening. So this is a bit more sophisticated. They do use a bit more calls, so it's going to cost you a bit, depending on the model you're using. But there are some very interesting techniques happening. Like also the other one is the propositional retrieval template, where it will actually do summarizations. So it will not only split it, but it will also try to summarize chunks of your context. So it will hopefully include that information and find it somewhere in the query results. There's all sorts of crazy techniques. None of these are yet implemented in LangChain4j. The semantic one is implemented in Llama Index, which is a Python library. And the other one, propositional retrieval, is implemented in LangChain, the Python version. So have a look at that, have a play with that. I actually, in my prototype, I implemented the chain of density, which is basically summaries which are linked to each other. And it does help because it has different flavors of the contents in your context. Cool. Enough talk. Let's have a quick look at the demo. Great. So you see, it looks a bit familiar to the CFP. So I've basically reused the menuing environment. And so what I did here is that I've actually categorized all the different LLMs and try to actually stay up to date of how much they cost, what is the window context of all these LLMs, and then you can see like, okay, the cost here, like, so at that time, GPT was the most expensive one. Gemini is not included because I had no access yet at that time. Also the context windows, you can see how much you can actually feed it. So as I said, Gemini is not included yet. So those are the ones which I can play with, which is, because what I want to do is I want to try out all these different providers, but also all the models they support, right? The other thing I wanted to do, which was actually Guillaume gave me this idea, is that I wanted to also play with the different embedding models, because different embedding models come with different dimensions. So you see here, there's a handful of embedding models that I supported, even the Cohere ones, which is not part of LangChain4j, but I implemented them myself. They range from 256 to from 384 to 1024 dimensions. I did not go beyond 1024 because like OpenAI, their embeddings, they go to 3600 dimensions. Now one dimension is one vector, so it's a float, right? So this is, if you give it a text, like how many talks did Brian Getz give, that sentence will be transformed into an embeddable vector, which will be represented by 384, whatever dimension or embedding I choose, by that many floats. So there might be 384 floats for that one sentence. And that sentence is like 10 words, but it still is 384 dimensions, right? So you need to really think about this, is that which embeddings do I use? Do I use, first of all, local embeddings? Do I use open source embeddings? Do I use commercial ones? What are their limitations? I didn't even think about the dimensions when I started doing this, and I'll come back to that one later on. But the thing I wanted to show you is that the import, so I implemented a nice UI to import your information. And then the cool thing is that you can do the splitting here. So you can do the debugging of the splitting. So for example, if I go to, let's say, let's do the frequently asked one. So here on the frequently asked, I can actually select which splitting technology or splitting strategy I want to use. So I'll do the recursive one, for example. And then in the demos, they do like, 550 and 25 overlap. Okay, let's use that. So now I'm splitting, and now I'm actually visualizing how the splitting is done. And just by seeing this visually, it looks like 550 is okay, but my default implementation was 350. So let's go back to 350, just to show you. Split. And you will see that certain sentences are actually not correctly split. And as a result, like here, tools in action are 30 minutes, and it continues, but it split it because it was 350. So just by visualizing where it splits and which technology you're using, you can actually already understand that, okay, if a sentence is split or there's at a certain point, especially with JSON, if it's going to split it in the middle of JSON, you're not going to get the right answers, right? So the splitting parameters are really important, the size and the overlap, but also the splitting strategy is really important, right? So with this, I could already basically do this. I could say, okay, split, and then I can store it in the DB. But storing in the DB means that I will take that chunk of text, embed it, so meaning I will convert it to an array of floats, which is the semantic meaning, and then I will put that array into the vector database, right? But choosing the right embedding is also already important. I have different results with the all mini LM versus the E5 small one. There's differences with this. So choosing the right embedding is something you need to actually test and try. It's not just a random, oh, I got a free local one, so I'll use that one. No, you will get different results. So you have to watch out for that. And so, okay, if I then do store it, it will store it in the database. Here I actually get all, that's the beauty. If you store it in the database, you get an array of floats. You have no idea what the information is because you can't reverse it. You cannot give it all the floats and reverse it back to text. So what I did is I actually kept track of that. I actually know what embedding represent what text. So this way I could actually debug the results. And when I saw Alex's demo, I was also like, oh, I should actually visualize these vectors. So I built like this one where I can actually go in there and see where the nodes are. But it's an eye candy, but it's not really useful because what I really wanted was to go with my mouse over the vector and then see what the point is. Because then, if I go in here and I go here, I know what the closest points are, so what is that information? This could be Brian Gett's first talk, and this could be the other 3 talks, but I wasn't able to do that. Now, it's open source. It's a lot of rain the following weeks. I'm expecting some pull requests from you guys, right? Anyway, going back to the demos. I did start 5 minutes later, Stain, so I still have 5 minutes longer, right? So no, seriously, we started 5 minutes later. In the RAG, the vector database is really important. If you didn't see Alex's talk, he did a great overview of that. Because I deploy this on Clever Cloud, which is where the CFPs are always running, they use Postgres. So I went with PGVector. So PGVector is an extra module that you can add, which allows you to actually store the floats into your database. Now, what I didn't know is that they use a certain index to do the similarity search, and this index is called the IVF flat index, but it has a limitation to 2,000 dimensions. So you can only store 2,000 floats in one go. So I wanted to use also the OpenAI embedding one, but that one goes beyond 3,600, so I was not able to do that. It actually cuts it off. So you need to be very careful is that if you go into production and you want to use the OpenAI embedding, you can't use PGVector. I think that's already worth just being here if you know this. And so the embedding, that's a whole story on its own. I could speak 2 hours or 3 hours about just embeddings on its own. But for people who don't know it, it's basically a numeric representation of the semantic meaning of the text that you're giving it, represented as floats. And that's already where the problem is. It's represented as floats. So it's a 16-bit floats, if I'm not mistaken, unsigned. But of course, if it's Java, there might already be some variations. The way you do that is that you just get an embedding model. You say embed as text, and it will return the embedding. And within that embedding, it represents the array of floats. Now, what's happening is that there are multiple embedding possibilities. You have the commercial ones as a service and the local ones, as I've already mentioned. But they do come with certain gotchas. For example, we started the CFP for Devox France, and they were doing this chat example in French, en français, and it seemed that the embedding I chosen, which was the mini one, isn't really multilingual. So it wasn't actually able to do this in French. So like I remembered Emmanuel Bernard saying, oh, it does not work. Qu'est-ce que c'est ça? Ça marche pas, et tout ça. And I was like, bloody hell, I'm using the wrong embedding. I should have used the Cohere version 3 one, which is a multi-language one. So it supports multiple language. So even this aspect you need to think about is not only the dimensions, but also the languages, if it's supported or not, of what you want to use. So I built my own embedding because Cohere actually supports multi-language. If you go to this GitHub one, I've implemented the full Cohere stack, so not only the embedding, but also the chatting and so on. And this will eventually appear also in LangChain4j. They can just use it. But the cool thing is that there I can actually use the multilingual embedding one as well. So keep in mind, embeddings have dimension sizes. And what's also crazy is actually OpenAI actually says that, don't worry, we can actually cut off the embedding size and it will still have enough semantic meaning to actually give you an answer. But ideally, you really want to have, you don't want to overshoot the model. And I actually did this presentation at Devoxx France, where I actually said that, well, this is a problem. For example, the local ones, the mini LM and the BG small, they have a maximum of 384 dimensions. But what LangChain is doing is it's actually cutting the code into pieces. So if you give it a longer text, it will still cut it in smaller chunks. And the founder of LangChain pinged me and informed me about that. So I double-checked in the GitHub repo, and rightly so. So that's what he's told me, like, watch out, it's actually there. Sure enough, yeah, they actually do partition it. So LangChain is a bit smarter on that level, that it knows the limitations of an embedding, and it will actually chunk it for you behind the scenes, which is cool. So I don't have to do that. But what's the trend? What's happening these days is that they are doing quantizations of these floats, where they say, like, okay, we don't need the full value. It might be that it's more than enough to actually have only 4 digits. Or the extreme is actually, no, binary, 1 and 0. What? 1 and 0? How's that possible? And it seems, I'll show you the next slide. Well, first thing, you need less disk space, because if it's 1 and 0s, you can have a much more compact storage compared to, for example, the full-blown ones. I mean, if you look at the Amazon, if you have to hold, 1 terabyte, it's going to cost you $43,000 a year. But if you do it with binary, it's only going to be 30 gigabytes, and it's going to cost you $1,300. So that's like, wow, that's interesting. And it seems Cohere supports this. So I implemented this implementation for LangChain. And so as you can see there, so that's the binary and the unsigned binary that you can now include. And there are some scientific studies that have actually shown that the bigger the model size, the smaller the difference, the delta difference between a binary, a bitnet, and a floating point 16, it's marginal. So there's like a 0.09 accuracy difference if you use bits versus floats if you're using a big model. So this is something you could think about, especially if you have to pay, well, sustainability. From this morning, it's going to cost you less to host it. It's going to cost you less to, implement and so on. So this is actually a very interesting trend, which you are starting to see in the last couple of months, and it's going so fast. Seriously, I'm trying to follow on all these trends, and it's like drinking out of a fire hose. But this is an interesting trend, and there's some interesting statistics where you're not really, so the top one is the binary one, and then you have the other dimensions with floats, and you can see, of course, that the latency to actually get a result is like 8 milliseconds versus 900 milliseconds if you use the full 372 dimensions. So there's a huge gain in response. And the accuracy, it's not such a big drop. So it goes from 0.78 to 0.99. So there is a bit of there is a difference, but it depends on your use case. If it's just answering speakers, it's not like it's financial transactions or whatever. So this could be an interesting step to go. And then I pointed out to the LangChain guys that, like, well, you're going to have to change your implementation of the embedding, because the embedding originally, it uses floats. You really want to have, you don't want floats, you want to at least maybe have just integers. So there's a bit of a mismatch there, mapping the results and the evolvements. So If you want to evaluate then your racks, what I did in the prototype, which again, I'll share later on where you can find it, I created these evaluation questions. So I have like, okay, I have Brian Getz, the question of Brian Getz. I can actually select this one and then say start evaluation, find me models, so I can have even Olama, which is running locally. I can have GPT-4, GPT-4. I can select the embedding model, and then I can say, okay, start now with asking these questions on these different models. I will not run this because it takes a bit of time, but you basically get this type of results. So you can actually see here what on the Brian Getz, who actually answered the one correctly, what the accuracy is, how much it took, so the execution of it, etc. So I was actually able to actually then now say, okay, this is what I'm expecting. So this is what I'm expecting, 4 talks, and these are the 4 sessions. And this is what I got from the model. So you could actually now actually debug basically the different variations, the different embeddings, the different models, etc. So yeah, it was a really eye-opener for me, for sure. And if you're going to do RAG in the future, this will be the pain points that you're going to go through, for sure. So I suggest just go to the GitHub repo and fork it and use it. It's there to be used. So lessons learned. Embedding models have an input limit. The bigger the embedding dimensions, the higher the hosting cost, which is rather obvious. Multi-language embeddings is a thing, so you have to think about that. If you're going to support French or other languages, make sure the embedding supports it. The quality of your embedding influences the quality of your results. So the bigger the dimensions, the better the results you will get, but it's going to cost you more. Leverage and test the power of different LLMs. So play with them. It's really like a kindergarten where you have no, it's like a toy story where you have all these toys and so on. Play with all the toys and try them out. Open them up. Look inside them. It's really that we're at a cowboy and western type of level for the moment. Make sure you log and debug your context similarity result. That's really important. And double check the vector database if it supports the dimensions you want to use, because like Postgres has a limitation there. And definitely use frameworks. But there was something else. It was like, I did this, and it was like very fun, and I really enjoyed myself. And my wife was going like, "Why are you so excited? Wow, you should know like this and that." So I don't care. Just stop talking. But I was like, okay, I've got this prototype. I dumped it. What should I do with it? And so there was at DevOps Belgium last year. I don't know if you were there, but during the opening keynote, I had Anton from IntelliJ come on stage. And one of the questions I did, I actually took a screenshot this morning, was like, he actually demoed an AI assistant in IntelliJ. And one of the questions I asked him is that, are you going to support local open source models? It's there, it's proof. And he didn't answer. I was like, come on, afterwards, I go, Anton, come on. You guys have a really cool OpenAI assistant, but it's based on probably OpenAI at the back end, and you have to pay for it. You have all these local models running locally on your machine. I want to use it locally. It doesn't cost me anything. I have fast response and so on. And they didn't respond after like 4 or 5 months. No reply. So I went like, fuzz it. I'll do it myself. So I developed my own plugin for IntelliJ, which actually allows you to run all the local models. Well, basically the expertise I built up with the prototype, I've built in this plugin. And the plugin is available on the marketplace. So who's using IntelliJ? Everybody. Well, let's say 95%. So the VS codes are happy as well. But you can actually download it. It's free. It's open source. And it allows you to actually have ChatGPT, but locally, using local models without going outside of the cloud. But of course, we have so many rainy weekends that I also implemented the cloud version once, right? And so this is the plugin. If you can see it on the right, we have the nice DevOps logo. And so if you click on this one here, you have all the different local models. I actually added Jan, which is also a local model which runs on your machine yesterday, so that's going to be released tomorrow. And if you don't care about privacy or you don't mind, you can actually include the open, your API keys in here. And if you do that, it will actually list them in the LLM providers that you want to choose. So this is the cool ones. You can have like Gemini, it's already there, but also Ollama, which is the one I really love. These are all the local models that you can run. So this is running, all these models are installed locally. It's about 50 gigs or something. It's about 4 or 5 gigs per model, depending on the size, of course. And then what you can do is that you can like say, I can select codes like this, for example, and then right-click if I want and say add to the context window. So now it actually has added this piece of code to my prompt context. So I'm doing RAG here, right? And then I can say explain, for example, whatever. And I'm using now Ollama with code Gemma, so the Gemma one. And it's now talking to the local Ollama instance and basically looking at the piece of code that I added and will come up with some response. While it's doing, because it's local, I'm implementing the streaming one as well, so you will see all the tokens, but the problem is I have to actually do the mapping to a nice visualization of that, so where you can really see, you know, the nice highlighting, and if it is showing some code, it will do the nice coding, etc. And doing that as streaming is a bit more difficult. But yeah, you can just do this stuff here. You can even add files which are open. Well, I've only got one file open, but you can add also files through this way. You can just write prompts and even say, like, I can remove this one and just say, hey, what's up? And then it will respond based on whatever model I'm using. And so here it's already saying, okay, well, whatever, right? But the cool thing is that you can now actually mix and match large language models. So I had like this prompt where I'm saying, here's a certain class that I wanted to actually implement using code Gemma. And then because I'm using chat memory, I can actually then switch to another model and keep the same memory, so the context remains there. And then I can ask like, hey, what do you think of the suggested solution from that other model? And go to a commercial one. And then the commercial one goes like, okay, well, this local one wasn't that good because it missed this and this and this and that, right? So you can do really some really crazy things where you basically are actually playing with different models and asking the different models to each other, what do you think of that? How should you improve it? And so while you're mixing and matching it, the end result is then the perfect code that runs perfectly in production, of course. That's what we hope. So I've implemented all these different things. It's all there. I have some other crazy things because it's still 5 months before Devoxx Belgium, so I still have lots of weekends and evenings that I can play with. Definitely one of the next versions I will release next week is the streaming, so you see the tokens appear, so it's go a bit faster. But what I really want to do is some really smart ragging using the abstract syntax tree of the class that you're using, where it knows like, it's inheriting from this class, it's implementing this interface, so it will include all these relationships within the RAG, and that's where, you know, the fun starts. Anyway. Lots of good stuff. I hope you enjoyed it. These are the links where you can find the projects, and my time is up, so thank you for your attention.